So let's try number 15 out of 12.6.
Yeah.
And we're supposed to show that this limit does not exist. Okay. So, what'd you try?
Well, it says to try.
You can just.
No, wait, no, it doesn't.
No, this one doesn't say to try anything. It does tell us that x can't be 0 and y can't be 0. They really need to tell me that?
No, you should be undefined.
Yeah. That's sort of the native domain of this thing anyway, right? Because if the bottom, right, if the absolute value of x times y is 0, that means x times y is 0. The only way that's going to happen is if one of x or y is 0, right? So this thing's a little bit redundant. They're just telling me about the domain of this function. Okay. It does have the kind of effect, right, of when I'm looking at the domain, right, x's and y's, I know I can't do my usual trick, right, which is to what?
Make x
Set
or
1
y
to 0.
Yeah, normally I'd set 1 equal to 0, right? I'd run in along the axes, but the axes aren't even in this picture, right? Crap. So, where's your... Yeah, that seems reasonable, right?
Yeah.
I could run in along these two instead, right? So that'd be saying, okay, what if x is y, right? So if x is y, then f of x and x. What's the notation I want here? What am I trying to do?
f of x, y, as x and y equals 0, 0, but let y equal x.
Okay, so I'm trying to take x and y, right? Except y is x, right? So I'm taking x and x tending to 0, 0. Oh, I should have said that at the beginning, right? I was trying to do the limit x and y tending to 0, 0 of fx and y does not exist. So, my bad. Okay, so I should take the limit x and x tending to 0, 0 of, what's this thing become? X squared over absolute value x squared. And what's that going to be?
No.
With the x squared, the absolute value is redundant.
Yeah, exactly. These absolute value bars, right? Those aren't doing anything because x squared is always positive, right? Okay, so I'm getting positive 1 out of this, right? Taking the limit x tending to 0 of 1. So I get, big surprise, 1. Okay. Is that enough to show the limit doesn't exist? No. What does this suggest to you?
Might be 1.
Yeah, if the limit exists, it's probably 1, right? In fact, if the limit exists, it has to be 1. So where else might you go?
So y equal to x?
Yeah, right? I'm not that creative, right? If I can't do x and y, I'm going to cock my head at it a little bit and do x and y. Right? So, what about the blue? What's that thinking?
What's negative x?
Y is negative x. Okay, so if y is minus x, I'm running the limit of
Minus x.
x and minus x to 0, 0, right? Really, that's just running x to 0. You guys all see that? And this one was also running x to 0. Okay, so I'm running x to 0 of what function now? Let's see, I get an x and then a minus x gives me negative x squared over
Absolute value of negative x squared.
absolute value of negative x squared.
Which would be negative 1 for the limit.
Yeah, because this is going to be positive without the absolute value bars, right? So I'm going to end up here with -1. Okay, so what do I say? the limit doesn't exist because coming in along y equals x, coming in along y is minus x give different answers. Cool. Good?
Why? I mean, oh yeah, yours is going to be a negative one. Okay.
Yeah, so what I got is when I come in along the blues, right?
Mhm.
And when I come in along the greens, I end up at different heights. Coming in along the blues, I end up a foot in the ground, right? Or a meter in the ground or whatever. And then in the greens, I end up a meter above the ground. Right? Those are kind of different places, so not going to work. Cool? Questions, thing?
So could you do this with a general y equals mx?
Sure. Yeah.
And then just try different m's at the end?
Oh, yeah. Yeah, that might actually have been a good idea here, right? You want to see that?
Sure.
That's sort of a good thought.
I was just, because from
Yeah, no, that's a really good thought. So we just want to come in
12
along
and 13,
some
it says
line,
to try
right?
that line.
Okay, so instead of those two, I'm just going to go like this, right? I'm just going to say, I don't freaking know, some line. So I'm going to think, okay, y is mx, right? So I'm going to get the limit x tending to 0, right? Or x and mx tending to 0, 0. You guys see that? Of what? What's my function going to be when y is mx?
mx squared over absolute value of mx.
Mx squared over absolute value of mx squared. Good. And so you'll get the limit of whatever, right? This stuff of mx squared over. Break that absolute value up for me.
Yeah, it can just be absolute value of m times.
Yeah, absolute value of m times x squared. That thing is, as I tell algebra students, a onesie. Right? That thing's multiplying by 1. So here you end up with really an answer of m over absolute value m. It's a bit funky, actually, right?
Is this supposed to be like some kind of constant or?
Yeah, it's constant with respect to x, right?
Yeah.
So,
So that would never become 1?
but this we know actually is either, if you take a number and divide it by its absolute value, you can only get 2 answers. What are they?
Positive or negative 1.
Positive or negative 1, right? You guys see that? So this thing's really plus or minus 1, depending on what m is. Right, it's plus 1 if m is bigger than 0, and it's minus 1 if m is less than 0. You guys see that? And it's totally undefined if m is 0, right? Okay, so what this means is that there's only 2 heights you can get to on this thing, right? Either you walk in from one of these 2 quadrants and you come up to a height of 1, or you walk in from one of these 2 quadrants and you come up to a height of minus 1.